Hello everyone. This study focuses on predicting the strength of 3D printed conductive composites under tensile load, a probabilistic modeling and experimental study. This study aims to assess how tensile speed, notch geometry, and layer orientation affect the mechanical behavior and fracture mechanism of 3D printed PLA carbon black, combining SEM analysis and Weibull statistics to evaluate damage and optimize material performance. Regarding materials and methods, this study was carried out in two main parts. Tensile test specimens was printed according to the ASTM 638 standard at different crosshead speed, and tests on sent samples with various notch geometries and layer orientations, followed by SEM, XRD, and Weibull analysis to evaluate fractures behavior, microstructure, and material reliability. For results and discussion, XRD was employed to characterize the crystalline structure of the PLA carbon black composite, providing insight into its phase composition and degree of crystallinity. Fractured sent specimens with different printed layer orientation were then analyzed using SEM to observe fracture surfaces and assess the effects of printing orientation on propagation mechanisms and microstructural features. Increasing crosshead speed enhances the material's mechanical strength and promotes more consistent behavior. It shifts the feeler threshold higher, extending the stable performance zone. On the other hand, notches create stress concentrations that weaken the material and reduce its ability to deform before breaking. They increase the risk of early failure and compromise structural reliability. As a conclusion, this study demonstrates the importance of notch geometry, tensile speed, and layer orientation in the design of 3D printed PLA carbon black components. By combining mechanical testing, microstructural observations, and probabilistic modeling, the resource provides a better understanding of damage mechanism and failure limits.